In this video, we will be solving this warm-up exercise. So this is the first of several warm-up exercises that you will find in workouts. These are here to help you see how to do calculations that are needed in later problems. The answers to all the warm-up exercises are in your answer pages. If you find the warm-up exercises easy and boring, go ahead and skip them and get to the main problems. You can come back and look at them if you get stuck later. So this exercise asks you to calculate the marginal utilities and the marginal rate of substitution for some common utility functions. These utility functions will reappear in several chapters, so it's a good idea to get to know them now. If you know calculus, you will find this to be a breeze. Even if your calculus is shaky or non-existent, you can handle the first three utility functions just by using the definitions in the textbook. These three are easy because the utility functions are linear. If you do not know any calculus, fill in the rest of the answers from the back of the workbook and keep a copy of this exercise for reference when you encounter these utility functions in later problems. So in this video, we will be solving these three utility functions, which are your linear utility functions. Here, for the given utility functions, we are asked to calculate the marginal utilities and the marginal rate of substitution. So let's first understand what do you mean by these terms. So your marginal rate of substitution, or your MRS, measures the slope of the indifference curve at a given bundle of goods. It can be interpreted as the rate at which consumer is just willing to substitute a small amount of good 2 or good 1. So mathematically, your MRS is equal to change in good 1 with respect to change in good 2, where this triangle represents the change. And this is equal to minus mu1 divided by mu2. Now what do you mean by mu1 and mu2? So your marginal utility for good 1 or mu1 measures the rate of change in utility associated with the small change in the amount of good 1. Thereby, your delta U is equal to mu1 delta x1. Similarly, your marginal utility for good 2 measures the rate of change in utility associated with a small change in the amount for good 2. Mathematically, your delta U is equal to mu2 delta x2. Now there are two methods to solve this question. First is involving the calculus, and the second is just using the basic definitions and calculating the marginal utilities and MRS. But note that both the methods are applicable into this question because these are simple linear functions. But as we progress along the question, you will see that it is comparatively easy to use the calculus in order to calculate your marginal utilities and the MRS. As here, your slope is constant throughout your indifference curve, as your indifference curves are linear. But that may not be the case always. So let's begin. We have the first utility function as u of x1 comma x2 is equal to 2x1 plus 3x2. Now this is a linear function, and according to the definition, MRS measures the slope of the indifference curve at a given bundle of goods. That means the slope, which is same throughout the indifference curve as the functions are linear, would be equal to MRS. And by basic maths, you must know that the slope of this function is minus 2 divided by 3. Thus, your MRS is minus 2 divided by 3. Now, let's calculate the marginal utilities. Here, I first calculated the MRS because it was a straightforward answer. But you will also see that if I use this formulation where I am calculating the marginal utilities first and then substituting into this equation, your MRS would be again equal to minus 2 by 3 for this particular utility function. Let's do that. From here, we know that delta U is equal to mu1 delta x1. So rearranging this, we would get that mu1 is equal to delta U divided by delta x1. Consider a consumer who is consuming some bundle of goods. Your consumption bundle is x1 comma x2. Now, how does this consumer's utility change as we give him or her a little more of good 1? This rate of change is called a marginal utility with respect to good 1. So from this consumption bundle, the consumer is getting the utility as u of x1 comma x2. And as we increase the consumption of good 1 by a very small amount, and this change is denoted by delta x1. So the consumer's new consumption bundle would be x1 plus delta x1 comma x2, where from this consumption bundle the consumer is getting the utility as u of x1 plus delta x1 comma x2. Thus the change in utility would be this utility subtracted by this utility, which is equal to u of x1 plus delta x1 comma x2 minus u of x1 comma x2 divided by this consumption bundle minus this consumption bundle. And since we are just calculating the marginal utility for good 1, we are keeping good 2 constant for the calculation purpose. So this becomes x1 plus delta x1 minus x1. Now I know that this might seem a bit complex at first, where we are using so much notation. So let's take a numerical example and apply to this particular utility function and then calculate your marginal utility using this formula. Suppose originally the consumer is consuming 2 units of good 1 and 2 units of good 2, giving him the utility of, that would be utility of 2 comma 2 would be 2 multiplied by 2 plus 3 multiplied by 2, as your utility function is 2x1 plus 3x2, and here our x1 is 2 and x2 is 2. So just substituting these values into this equation, we would be able to get the utility for this consumption bundle, which is nothing but 6 plus 4, which is equal to 10. Now suppose the consumer increases his consumption of good 1 by 1 unit, which means now he is consuming 2 plus 1 comma 2, as we are not changing the consumption of good 2. So this would be equal to 3 comma 2. Thus the utility from the consumption bundle 3 comma 2 would be u of 3 comma 2, which is equal to twice multiplied by 3 plus 3 multiplied by 2, which is 12. Thus our marginal utility for good 1 is equal to this minus this, which in our numerical case would be utility of 3 comma 2 minus utility of 2 comma 2 divided by x plus delta x1, which is your 3, minus x1, which is your 2 in this particular case. So this would be 12 minus 10 divided by 1, which is equal to 2. Thus your mu1 is 2. If we change the amount of good 1 by 1 unit, your marginal utility of good 1 changes by 2 units. Now, following the same process, we would be able to calculate the marginal utility of good 2, where instead of increasing the amount of good 1, now we would be changing the amount of good 2. So let's do that. Now from here, we know that delta u is equal to mu2 multiplied by delta x2. Again, rearranging this, we would be able to get mu2 is equal to delta u with respect to delta x2. Now here what happens is, initially if the consumer was consuming x1 comma x2, then if or she changes this consumption of good 2 by a very small amount such that the new consumption bundle becomes x1 comma x2 plus del x2, such that the utility derived from this consumption bundle is u of x1 comma x2, and utility derived from this consumption bundle would be u of x1 comma x2 plus del x2, and substitute it into this equation, we would be able to get mu2 would be equal to the change in utility, which is equal to this minus this. I'm again repeating here, everything is remaining the same, just like we did for marginal utility of good 1. It's just now, since we are calculating the marginal utility of good 2, we are changing the consumption of good 2 and hence doing the corresponding calculations. So don't get confused. Would be equal to u of x1 comma x2 plus del x2 minus u of x1 comma x2 divided by x2 plus del x2 minus x2. Now let's again quickly take a numerical example. That would be, suppose the consumer is initially consuming 1 comma 1, that is 1 unit of each good, and now he changes the consumption of good 2 such that now he is consuming 2 units of good 2, or you can consider it as that now he is increasing his consumption of good 2 by 1 unit. So let's calculate the corresponding utilities, which would be u of 1 comma 1 Now note that the utility function remains the same. So if we are calculating marginal utility of good 1 or marginal utility of good 2, it does not matter since the utility function would be same. So this would be 2 multiplied by 1 plus 3 multiplied by 1, which is equal to 5. And the utility corresponding to this consumption bundle would be u of 1, 2, which is equal to 2 multiplied by 1 plus 3 multiplied by 2, which is 2 plus 6, which is equal to 8. Thus your mu2 is u of 1, 2 minus u of 1, 1 divided by 2 minus 1, which is equal to 8 minus 5 divided by 1, which is equal to 3. Thus your marginal utility of good 2 is 3. Now let's calculate the MRS and verify if we are able to get the same value of MRS if we substitute the value of mu1 and mu2. Now your MRS is equal to minus of mu1 divided by mu2, and mu1 is 2 and mu2 is 3. Thus your MRS is minus 2 divided by 3, which was something we got earlier. Now let's move on to the next utility function, which is 4x1 plus 6x2, where again we have to calculate your marginal utilities and marginal rate of substitution, and your MRS measures the slope of indifference curve at a given bundle, where this is your mathematical formula for MRS, and your MUs are your marginal utilities for good 1 and good 2. Now while solving the utility functions 2x1 plus 3x2, we learned these two formulations for your mu1 and mu2. So here I would be directly using these formulations for the utility function 4x1 plus 6x2. Now again MRS measures the slope of the indifference curve at a given bundle of goods, and since this is a linear function, your slope remains the same throughout the indifference curve. Thus, your slope would be equal to MRS, which would be equal to minus 4 divided by 6 in this particular case, which is equal to minus 2 divided by 3. Hence, your MRS is minus 2 divided by 3. Now, let's calculate your marginal utilities. First, we will do the calculation for your mu1. Suppose initially the consumer is consuming x1, x2, and then he increases his consumption of good 1 to x1 plus del x1, x2. Where from this consumption bundle he is getting the utility of ux1, x2, and from this consumption bundle he is getting the utility of u of x1 plus del x1, x2. Let's take the numerical examples and calculate these values. Suppose initially the consumer is consuming 1 unit of good 1 and 1 unit of good 2, and then he changes his consumption to 2 units of good 1 and 1 unit of good 2. Thereby he is increasing the consumption of good 1 by 1 unit. That is, the change in consumption of good 1 is, or delta x1 is equal to 1. Let's quickly calculate the utility values. That would be u of 1, 1, which is equal to 4 multiplied by 1 plus 6 multiplied by 1. As now the utility function takes the form as 4x1 plus 6x2, and in this particular case we are taking the value of x1 as 1 and x2 as 1. So substituting this, we would be able to get 4 multiplied by 1 plus 6 multiplied by 1, which is nothing but 10. So this is equal to 10. Now let's calculate the utility of 2, 1, which is equal to 4 multiplied by 2, as now your x1 is 2, plus 6 multiplied by 1, which is 8 plus 6, which is equal to 14. Thus this becomes utility of x1 plus delta x1, x2 is your utility of 2, 1, which is equal to 14, minus u of x1, x2, which is utility of 1, 1, as in our case x1, x2 is 1, 1. So this would be 10 as we calculated here. So this is 10 divided by x1 plus del x1, which is equal to 2, minus 1, which is equal to 4 divided by 1, which is equal to 4. So your mu1 is now 4. Similarly, let's calculate your mu2. Instead of changing the consumption of good 1, we are changing the consumption of good 2, such that if the consumer is originally consuming x1, x2, then his changed consumption would be x1, x2 plus del x2. Let's keep the original consumption same so that we don't have to do the calculations again and again. That is, if he is originally consuming 1, 1, then his new consumption would be 1, 2, where he is increasing his consumption of good 2 by 1 unit, such that your del x2 is equal to 1. Let's calculate the corresponding utilities. U of 1 comma 1 is equal to 10 as we calculated here. Since your utility function is the same, let's quickly calculate the utility of 1 comma 2, which would be 4 multiplied by 1 as here x1 is 1, plus 6 multiplied by 2 as x2 is 2. That would be 4 plus 12, which is equal to 16. Thus, substituting all the values here would be your new utility calculated from here would be equal to utility of 1 comma 2, which is equal to 16, minus utility of x1 comma x2, that would be utility of 1 comma 1, which is 10, divided by x1 plus x2, which is equal to 2, minus x2, which was 1. So this is equal to 6. So your marginal utility of good 2 is 6. Now let's calculate the MRS, which is equal to minus mu1 divided by mu2. Now your mu1 is 4 and your mu2 is 6, which is equal to minus 2 divided by 3, which is this, as we calculated before. Now let's move on to the next part, where your utility function takes the value of a x1 plus b x2. Again, the slope is equal to MRS. Now here, instead of taking the particular values of a function, we are just doing what happens in a general case, where a can be any value and b can be any value. It could be a real number, it could be a whole number. Thus, this would be equal to minus a divided by b. MRS is minus a divided by b. Note that this is a general form, where instead of taking any particular value, the function is taking a general form where a and b can be any real number. It could be 0, it could be 1, it could be 1.2439, anything. If you compare this with your utility function as 2x1 plus 3x2, here your a is 2 and b is 3. Thus, your MRS was minus 2 divided by 3. Now let's calculate the marginal utilities. Note that what happened when we calculated the marginal utility here. It was marginal utility of good 1 was nothing but the coefficient of x1, which was 2. Here the coefficient of x1 was 4, hence the marginal utility of good 1 was 4. Thus, if I generalize it, the marginal utility of good 1 without doing any calculation would be straightforward. The coefficient of x1, which in this case is a. Thus, your mu1 is a. Similarly, here your mu2 was nothing but the coefficient of x2, which was 3. Here it was 6. Thus your mu2 was 6. Similarly, your marginal utility of good 2 would be b, giving you the MRS as again minus a divided by b. So that would be minus of mu1, which is a, divided by mu2, which is b. Thus your MRS is minus a divided by b, which you can also verify doing the calculations and making the substitutions into mu1 and mu2 with this long formula, which I am not doing here, since I wanted to explain you how the general form works in case of your linear utility functions. Also, your linear utility functions are nothing but the utility functions for your perfect substitutes. So if I summarize the entire question, I would say that in general, the preferences for perfect substitutes can be represented by the utility function of the form u of x1 comma x2, which is equal to ax1 plus bx2. Here, a and b are some positive numbers that measures the value of good 1 and the good 2 to the consumer. Note that the MRS or the slope of a typical indifference curve is given by minus a divided by b, which we calculated here. Now, after doing the calculations using your definition method, let's do the calculations using the calculus, because I earlier did it for the people who are not well versed with the calculus. As I told you before, we need calculus as we progress along the question. So let's quickly solve these linear functions using your calculus. Also note that how the definitions of MRS and marginal utilities have changed. Earlier, instead of this partial derivative, we were using the change or the triangle. But now, since we are using the calculus, hence we are using the partial derivative, as utility is function of two variables that are good 1 and good 2. And as I told you before, if I am calculating the marginal utility of good 1, I am keeping the good 2 constant for calculation purposes. Let's begin. Your first utility function is 2x1 plus 3x2. and MRS is nothing but minus mu1 divided by mu2. So let's first calculate mu1 and mu2. From here I know that my marginal utility is the rate of change in utility associated with the change in amount of good 1. That is, I have to partially differentiate the utility function with respect to good 1. So differentiating this with respect to good 1, and for that I have to keep the good 2 constant. So this becomes the constant, hence this would be 2 plus 0, as this is constant and the derivative of constant is 0, so the derivative would be 2. So your mu1 is now 2. Now in order to calculate the marginal utility of good 2, you have to keep the good 1 as constant. So differentiating this, I will get 0 plus 3 is equal to 3. Hence your marginal utility of good 2 is 3. This is 3. Now substituting the value of mu1 and mu2 into this equation, I would get minus 2 divided by 3. Your MRS is minus 2 divided by 3. Let's move on to the next utility function, which is 4x1 plus 6x2. Again, your MRS is equal to minus mu1 and mu2, and in order to calculate the MRS, let's calculate the marginal utilities first. Your mu1 is equal to partial derivative of utility with respect to x1, and for that we would be keeping the good 2 constant. Hence the marginal utility for good 1 is 4. So this becomes 4. Since this is very simple derivatives, that's why I'm not going in much detail. You can always refer to the formulas for your derivatives from your basic maths courses, and the marginal utility for good 2 would be 6. As here we are keeping x1 constant. Now substituting these values into this formula, we would be getting MRS is equal to minus 4 divided by 6, which is equal to minus 2 divided by 3. So filling up the table, that would be your marginal utility of good 2 is 6. And your MRS is minus 2 divided by 3. Let's move on to the next part. Now the utility function is of the form ax1 plus bx2. Slope is equal to MRS, which is equal to minus mu1 divided by mu2. So let's calculate mu1, which is nothing but a, or the coefficient of x1, and mu2 would be b. Thus this would be minus a divided by b. So filling up the table, this becomes a, this becomes b, and this is minus a divided by b. Now note that this was very basic calculus. You could have done it using the definition method, which we did it before, or you could have easily done it with the calculus. As you can see, it just took us seconds to calculate your marginal utilities and MRS using your calculus. I personally prefer using calculus, so I would be using calculus throughout the entire chapter.